So here I've got a bar. I'm trying to figure out what force so that I don't go past 150 megapascals in tension. Again, recognizing that I've got a couple of different stress concentration here. One at a fillet and then one at a hole in the inside. Okay, so we'll start with at the fillet. Okay, so again, well, let's just, I guess, start. So W over H, okay, I'm looking for which curve I'm going to look at, okay? So W is the thicker one, which is 60. H is 30, so I get a WH over 2, which means I'm going to follow this line right here, okay? R over H, which is across the bottom here, okay? My radius is 15. And again, my H is the smaller one, so that's 15 over 3. That means I have an R over H of 0.5, which is right here. So what I'm looking at here is where this guy intersects with the W over H equals 2 curve, which is right here, which hopefully you follow across and recognize that K is 1.4. So that's my stress concentration given these dimensions at the fillet. Okay. Then I plug in my equation where my maximum, I don't want to go past 150. Okay. My average is that load P over HT. So that's the smaller area. So that's why I have the 0.03 thickness of 20 millimeters. K of 1.4. Solve for P, I get 64.3. Now, I need to do the same thing for the hole, and then, of course, whichever P is smallest is the one I need to go with. So moving on to the hole, I have a different plot looking like this. For this, I need to look up 2R over W, where my radius is 12, or 2R, my diameter is 24. W is 60, is that width where the hole is. Okay, so I get that to be 0.4, which is right here, which approximately equals K of 2.2. From that, I plug that into the same equation. Again, my sigma allow, my sigma max is 150 megapascals. K is 2.2. My sigma average is right here, and that's basically the average right at the max point of the hole. Again, that smallest area is what I'm looking at. So I take that P that I'm looking for, W minus T, 2R over T, which again is just the cross-sectional area on the outside of those triangles. Solving that for P, I get 49.1, which is less than what was on the previous, which was 64 point something. So this is actually the answer because it is the smallest of the P. I cannot go above that. That's the maximum force that this can handle so that it doesn't break given those stress concentrations.